Sir, sorry for disturbance.
Tell me.
May I please get a short introduction of you?
Actually, I am Sanat Kumar. So I have 15 plus years of experience in both training related into VLSI and some couple of companies. I worked as a VLSI like RTL engineer, RTL engineer. So both industry as well as trainer related experience I have. So most of the experience I have into training only, training related thing. So I trained so many candidates. So now they are in good companies and thus. So this is my actually basic. I'm basically from Hyderabad. So parallelly, I'm taking the training related to online only. This is my profile.
Okay, great.
Is it
Thank you,
fine?
sir.
Is it fine? Yeah, yeah,
Yeah, thank you. Thank you, sir.
yeah. No issue. Whatever the from the basic, from the scratch onwards, I will teach you. Okay. And so, as a part of this introduction, so from tomorrow onwards, we will start our session. We'll start with digital. Okay. Digital electronics. Today, I will tell you. I will exp means I will tell you a brief introduction to the VLSI and what are the job opportunities in VLSI and semiconductor industry.
Okay.
Is it fine? Shall we move forward?
Yeah.
Okay. Yeah, yeah. Anything you have doubt and any difficulty facing in my teaching, anything is there, just you can interrupt me and you can ask me. Okay. Or otherwise, after completing this session, I will give some 10 minutes of time. So you can ask your doubts and all those things. Okay.
Okay,
Is
okay,
it
sir.
fine? Yeah.
Yeah, yeah.
So, yeah. So here, if you see the VLSI semiconductor industry, so basically, my screen is visible, no? Hello. I
Yes,
shared
sir.
my screen. My screen is visible, no?
Yeah, yes, yes, sir. Visible.
Yeah, yeah. So basically, in VLSI, actually, what is VLSI? Can anyone say what is VLSI?
Very classical.
VL,
Yeah, tell me. Anyone?
VLSI is, sir, a very large scale integration in
Hmm.
which we integrate the millions of electronic components
Hmm.
on same chip
Hmm.
to make it more efficient.
Okay. So normally, yeah, it's correct. So normally in the olden days, you have actually they invented by using they invented this they used the vacuum tubes. Okay. So after that, what happens? They invented the transistor. Three scientists they invented the transistors, yeah, and you have so SSI, okay, small scale integration,
Yes,
MSI, medium scale integration. Okay, LSI, large scale integration, and
yes,
VLSI, very large scale integration, and you have VLSI also. VLSI means ultra large scale integration. Okay, so small scale integration means some 10 to 100 grades, 100 transistors we are integrating. Okay, medium scale means up to 1000 to 10,000 gates. Okay, and LSI means up to 1 lakh gates. Okay, and VLSI means what you are integrating some 100 crore transistor, millions of transistors within
millions
an
of
IC.
them. Yes.
Okay, within an IC. So you know that Moore's law. Moore is a scientist. Okay, Moore is a scientist, or he's the founder of Intel. He actually uh, he given a statement like the number of transistors will double for every 2 years. Okay, every 18 months or 2 years. So till now the Moore's law statement is satisfying. Okay, so we are in which technology? So always all are talking about technology. What is the technology? So we are in 3 nanometer technology or 2 nanometer technology. Okay. Somebody will make the IC with the 10 nanometer technology. What is the technology? Can anyone say? Hello, I'm audible.
Yeah, yeah, sir.
What is the technology? So normally you have a MOSFET. You studied upon MOSFET.
Yeah, sir.
MOSFET, actually MOSFET, mainly the mainly MOSFET you have like here you have silicon dioxide, and here you have gate and source and drain. Okay, the distance between drain and source. Okay, so source and drain we call as channel. Okay, one second. పవర్ పోయింది ఒకసారి నా సెల్ ఆ పవర్ పోయింది కదా చిన్న కానీ మళ్ళీ టైం పడుతుంది. Yeah, sorry for the interruption. There is power cut down in my area. Is it audible?
Yeah, sir.
Yes.
Okay, yeah, there is a power cut down. Okay, yeah. So normally, like this is actually we call as the channel length, the distance between source and drain. We call as the channel length. Okay, so we are integrating the transistor with this much of channel length, this many transistors. That means transistor we can't see with our naked eye. Okay, so the 2 nanometer. So channel length is 2 nanometer. Okay, did you
So,
understood?
yeah.
Okay, yeah.
So,
So that means here semiconductor companies, actually there are three types of companies will be there. Okay, one is product based company, service based company, and EDA company. Product based companies means what? Which will produce their own ICs. Okay, so normally in VLSI we'll talking about modules. Okay, modules, there will be a hierarchy. Okay, and IPs, what are IPs? Intellectual properties. Intellectual properties. Okay, and we call as SoC, system on chip. Okay, so modules are nothing but like we are studying about the combination circuits like adders, subtractors, multiplexers, and sequential circuits like counters. We call as the modules. Okay, IPs are nothing but like FIFO. FIFO is one IP. Okay, RAM is one IP. Okay, these all are nothing but we are call as IP. Okay, so these are all IPs are combined together. We call as a SoC, system on chip. Okay, that we'll discuss. So product based companies are nothing but they will produce their own ICs. Okay, so can you say some product based companies? Hello.
sir, the product-based companies are like Qualcomm, Cadence.
Qualcomm. Cadence is a EDA company. Okay,
Okay.
only one trainee is responding. What about others? I'm expecting others also should participate. Okay, whatever you know, is it correct or not? Please tell me. Okay, so yeah, AMD, Intel. Okay, and Qualcomm, okay, NVIDIA will produce graphic CPUs, not GPUs. We call it GPU. Okay, so GPUs. All these are what product-based companies. Service-based companies are actually they will not produce any product, but they will give the service based on the requirement. Either it may be front end or back end. Okay, and EDA companies means actually like in olden days, like designing or getting the layout for 10 to 100 transistors manually, it is easy only. But actually, VLSI means what you are integrating some 100 crores of transistors, billions of transistors you are integrating within an IC. So manually, it's not possible. So we need to take the help of what EDA tools, electronic design automation tools. Okay, so the tools which will produce Cadence, Metagraphics, Synopsys, these companies will develop the tools. Okay, so for front end, you have some tools like Xelium, okay, or Xelium. Some types of tools are there, and in back end also like Cadence, Notch tools are there, physical design, and Mentor Graphics also. You have Model Sim, Quasta Sim, okay, like that Mentor Graphics, and from the synopsis you have a tools from front end. You have VCS compiler, okay, VCS design compiler. So all these EDA companies, product based companies and service based companies will always synchronize up to meet the technology deliverable, okay, with the help of what VLSI engineers. Okay, now you understood the companies are there. What are the companies are there?
Sir,
Hello.
are these
Yes, sir.
all
Yeah,
tools
yeah.
open source
So
or
next you
we
see,
need to have proper access to them?
mainly VLSI target devices are two types. Okay, VLSI target devices are two types. One is FPGA and next one is ASIC. FPGA, you know what is FPGA? Field Programmable
Gate array.
Gate Array. Programmable Gate Array. Okay, Field Programmable Gate Array. Okay, and ASIC is Application Specific Integrated Circuits. Okay, so FPGA means you already studied in your BTech like PLA, PAL, and PROM. You studied or not? You studied or not in digital? You studied, no? This
Uh,
one, programmable logic array, programmable array logic, programmable
y-
read-only
yeah,
memory.
yeah, sir.
Okay,
Yeah, sir.
yeah. So FPGA means what? A field programmable gate array. So this is reprogrammable. This is what reprogrammable. Okay, and reconfigurable. Suppose like FPGA is actually a board. It consists of like it consists of configurable logic blocks, CLBs. Okay, in CLLBs you have LUTs, lookup tables and muxes. All this will be there. And for this FPGA, suppose if you write the code for any simple decoder circuit, okay, in HDL, like hardware descriptive language, okay, it may be Verilog or it may be VHDL, okay. So when you generate the bit stream, so that you are porting into that FPGA, that FPGA will work as what as decoder. FPGA will work as decoder. Okay. After that, you can erase that code. Suppose for FSM, you are writing the code. That FSM will work as a this FPGA will work as a decoder. So we can reprogram. Okay. Whereas ASIC, ASIC means what? In your so many ASICs, like your mobile phone is one ASIC, or your smartwatch is one ASIC, okay, and your smart TV is one ASIC, okay. So that means whatever the ICs we are using for ASIC, those are only used for specific application. Okay, so we can't take that IC. Suppose whatever the IC present in the smart TV, we can't use in the smart ACs or ACs. Okay, so that IC which is useful for that specific application only. Suppose if you take airbags, okay, in automobiles, so many ICs are there that is operated at different applications like airbags, engine control, brake control, okay, and ignition system, like that. Different ICs will be there. Okay, so here this is actually full custom. Full custom means suppose you are developing with the 3 nanometer technology. Okay, so 3 nanometer technology means there are no standard cells are there. Okay, so you need to come from the scratch. Okay, you need to make 3 nanometer IC. Okay, you need to come from the scratch. Okay, so this is actually this is made with bulk production. Okay, so it is made with bulk production. Why? Because when you make this bulk production, so cost per chip also decreases. Okay, so and it will take low power. Okay, so mainly that VLSI target devices are actually before going into ASIC, you will do the R&D in FPGA. R&D in where? FPGA. Okay, so this is actually ASIC. Okay, yeah. Did you understood the difference between ASIC and FPGA?
Yes, sir.
Yeah, yeah. So this is actually ASIC design flow we call it. Okay, irrespective of your means your specialization. Suppose you may be RTL design, you may be verification engineer, or you may be analog layout engineer, or you may be physical design or post silicon verification engineer. Any type DFT engineer, static timing analysis. First, they will ask for this ASIC design flow. They will ask. Okay, this is a common interview question. They will ask. They will ask. Okay, first design specification. Design specification means what? Whenever you are making this IC. So this IC first, there will be like in every company, the architectural engineers will be there. Okay, senior engineers. Okay, like 30 years of experience, they will take the specifications from the client. Okay, and this IC, with this VLSI IC they are using for which purpose? That may be they are using for like security, or they are using for computer based, or they are using for space related. Okay, they are using for network. First, they will decide. Okay, they will decide for what purpose they are using this IC, and they will see for how much power it will take, how much area it will take, and how many pins are required for that ICs. It's like a blueprint only. Okay, so specifications will be taken by the architect from the customers, from the client. Okay, so client, suppose so they will take the specification, and suppose they want to build a CPU. Okay, so after taking the specification, they will do the architecture. Okay, so architecture means you studied about computer architecture. So computer architecture means you are going to study about all the CPU computer related architecture. Suppose if you want to design CPU. Okay, CPU consists of what? You have arithmetic logic unit, and memory unit. Okay, and control unit. Okay, and bus interface unit. Okay, so they need to make the planning. Okay, suppose like if you want to build a building. Okay, what you need to do? First, you need to go for planning, no? So where should be like hall, kitchen, bedroom. Okay, so all these things will be done in the architecture. Okay, so architecture. Okay, designing. And after that, micro architecture means what? So in VLSI, there are like two types of abstraction levels are there. Okay, one is top down approach. Next is bottom up approach. Okay, top down approach means what? First system level will come, and next module level, module level, and next module level, and next gate level, and CMOS, we made with CMOS, and next device level. Device level is a low end level. Okay, so system is divided into modules. Module is divided into gates. Okay, modules means you have combination circuits, sequential circuits. Okay, and this combinational and sequential circuits will made with gates. Okay, so gates are made with CMOS circuits. CMOS are made with the devices like MOSFETs. Okay, and bottom up approach means device level, and next you have CMOS, and next gate level, okay, and module level and system level. So bottom up approach you will not prefer. Mainly you will prefer top down approach only. So here I want to design a CPU. CPU is a system. So system again divided into what module level, that is micro architecture. So you need to design separate modules like ALU, micro memory unit, control unit, and bus interface unit. All this we need to do micro architecture. Till this is it fine?
Yes.
Yeah. Next,
Yes, sir.
next comes the first part, RTL design. Okay, RTL design means what? Register transfer level. Register transfer level. Okay, so register transfer level means, so before this one more is there. Okay, so in order to write the RTL code, it should be strong in the digital digital electronics, or we can call as digital design. Okay, so digital design is common for all the fields in the VLSI. You are studying like RTL design or design verification or physical design or embedded system design, anything, digital is fundamental. Okay, so with the digital, if you are comfort, it's it's a basic foundation. Okay, so if you are good at digital, then you are writing the RTL code by using two languages, that is HDL. Okay, HDL is a hardware descriptive language. Hardware descriptive language, you have two types. One is Verilog and next one is VHDL. Verilog and VHDL. Okay, so what is this? Mainly in the programming language, there are two types of languages. No, what are those languages? Can you say? High level language and hardware descriptive language. Okay. So what is high level languages? C, C++, Java,
Python.
Python. Okay. HDL means you have Verilog and VHDL. Okay. Can you say what is the difference between Verilog, this high level language, and HDL? Can anyone say?
Sir, I think that from the very high level language, we cannot do the physical implementation on the IC boards like FPGA.
Mm-hmm.
And by using the Verilog programs, we can implement the physical, we can do the physical implementation on FPGA board. We can do the physical
Okay.
verification and see that.
Okay. Okay. Yeah. In simple word, like if I tell you, like suppose this software people are there now. Software people, they will make the application. Okay, they will make the application. Suppose they are developing application for bank related thing. So what they will do, they will make the application and they will give that application to bank people. Bank people can use that. Okay, they will not make the hardware. No, just they will use the processor. Okay, this HDL, by using HDL we can make the hardware. Okay, there is a term called synthesis. By using synthesis we can make the hardware. Okay, so this software people will work on the processor, whereas hardware HDL. So this HDL, by using HDL we can make the hardware, we can make the CPUs. Okay, so that is the difference between software language and hardware descriptive language. Okay, so here different types of, did you understood the difference between high level language and HDL?
Yes, sir.
Yeah. Okay. So here you see RTL is actually in the Verilog you have different modeling styles are there, like switch level modeling, okay, and gate level modeling, okay, and next data flow modeling and behavioral modeling. Okay. So this data flow modeling and behavioral modeling is synthesizable. Synthesizable means what? We can convert into hardware. Okay. Switch level and gate level can't be synthesizable. Okay. That means we need to write the synthesizable code. Synthesizable code means what? The code which can convert into hardware is a synthesizable code. Okay. So VHDL is a very high speed integrated circuit hardware descriptive language. The differences we'll see. Okay. Differences we'll see. Okay. So for this, you need a RTL engineers. RTL engineers. Design. RTL engineers. RTL engineers will write the code. Okay. And here for after writing the code for verification, you can write the test bench. You can write the test bench. They can write the test bench and they can verify. So they can write up to IP level only. Suppose for FIFO they can write. Okay. And some RAM also they can write that and they can verify. Okay, in the verilog. Okay. But so suppose if you go for SOC, system on chip. Okay. So verification by verilog is not possible. You need to go for what? System verilog and UVM. So the verification people, design verification people, okay, design verification people job is this design people will design the circuit. This verification people will write the test benches and they will checking for the bug. Any bug is there, okay, any error is there in this design, okay. So these both will work together. So in any company you take, you have separate design engineers, okay, RTL design engineers, and you have separate verification engineers. Okay. So there is a separate role for RTL design. So there is no combined role will be there. So RTL designer engineer's role is to write the RTL code and verification engineer's role is to verify your design, whether your design is correct or not. Okay. So so that means this RTL design engineers will check up to code coverage, they will check. Okay. But here verification engineers will check for functional coverage also. So they will check for the functional coverage. So that means there are some bins and hits and bins will be there. So if you are getting 100%, that is required in 100% coverage, okay, and then verification is passed, okay. So system verilog is actually we call as hardware design. We can do the design by using system verilog also. Hardware design verification language, HDVL we call it. Okay. So many concepts will be there in the system verilog. Okay. Like more main thing is OOPS, advanced OOPS. OOPS means object oriented programming. Okay. OOPS concept will come in the system verilog or like polymorphism, inheritance. Okay. Inheritance. You have a class as child class, and here if you are giving the stimulus, so directly constant stimulus we are giving. Okay. Here we have like different types of stimulus, like different concepts will be there in the system verilog. Okay. Constraints will be there. Okay. Randomized constraints will be there. Okay. So randomly we can give the test cases in the system verilog. Okay. And UVM is not a language, it's a methodology. It's a methodology. So that means here system verilog, it's a robust. That means suppose you are verifying for I2C protocol. Next you want to switch on to SPA protocol. If you want to verify, so you need to come from the scratch. Okay. So but UVM is actually it's a standardized verification process. All the companies will follow. Okay. So it consists of some predefined classes and factory register predefined classes for every driver class, monitor class. Predefined classes will be there. Okay. And factory registration. How we are accessing the classes means that is a factory registration method is there. Okay. So mainly you are verifying in UVM only, universal verification methodologies. That is not a language, it's a methodology. You are using SV under UVM. Okay. So this they will work under these two, system verilog and UVM. System verilog and UVM. Okay. So if design is met, it will go to the next step. If design is not met, again it will go, it will stay here only. Okay. Logic synthesis means what? Synthesis, I told you, synthesis means, so after verification you will get a gate list, gate level net list. Okay, net list file you will get. Okay, so you are getting the circuit in terms of gates. Okay, so the circuit will be converted into gates only, no? So in terms of AND gates and OR gate, NAND gates and NOR gates, NAND gates and NOR gates, you know, universal logic gates. Okay, and in terms of muxes and D flip flops, they will convert. Okay, so synthesis means they will work under power, performance, and area, PPA. Power, performance, and area. Okay, nowadays power is should take low power, performance should be more, and area should be less. Okay, so day by day what is happening, you are using handheld devices, mobile. So whatever the mobile is there, whatever the computer is doing, that mobile is doing whole thing. Okay. Suppose if you take Apple, okay, Apple A17 series. So Apple, it's a, it use ARM processor. Okay. And also in Apple, this computers are there. Computers also they'll use ARM processor. Okay, mainly RISC. ARM is actually RISC. Reduced instruction set computer. Okay, so it consists of like load and store architecture, all those things. So the future is RISC-V. Okay, RISC-V means actually due to some monopoly. So we need to go for ARM, Intel, and different processors. We need to go and we need to buy. So there is a common general processor will be there. RISC-V. RISC-V is reduced instruction set computer 5. Okay, so you can develop that. You can study about RISC-V and you can work on that RISC-V. Why? Because future is RISC-V only. Okay, so the future will come at RISC-V. Okay, and DFT is actually testing. So whether like by using some scan level testing or BIST testing, you are checking whether your chip is proper, correctly matching or not. You are checking. DFT people will be there. DFT engineers will be there. Okay, and logic equivalency check, whether your logic equivalency means what, whatever the logic you wrote, it is verifying with your design or not, that will check in the logic equivalent. Okay, and static timing analysis means actually like we need to do the simulation, means what, we need to verify the correctness by using the waveforms. In the static timing analysis we can verify by using timing. Okay, like setup time, hold time, and clock tree synthesis, like different concepts will be there in the STA. Okay, clock tree jitter, okay, clock skew, so that with related to the delays. Okay, in digital we'll assume that propagation delay is 0, but we need to consider some propagation delay. Okay, so if design is met, it will go to the next state. If design is not met, again it will come to the previous state. PD flow, physical design. So this physical design people will take the different inputs from the front end. So up to synthesis we call as a front end. Up to synthesis we call as DFT is the testing. So up to synthesis we call as the front end. From here it is a back end. Okay. So in physical design you have different floor planning, placement, routing, clock tree synthesis, all those things will be there. And parasitic extraction means like RLC. Uh, every wire have some resistance and capacitance. RC extractions will come in the parasitic, and STA will be there, preload STA and post-load STA. Okay, so if design is met, it will go to the next step. Otherwise, it will go to the PD flow. So this physical design engineers will take the inputs and they will do the low level design, like transistor level design they will do. Okay. After that, verification will be there in the this is actually post silicon verification we'll call physical verification. And after that, GDS2 file will be generated. GDS2 file means graphical design system, that is given to the foundry, that is going into the fabrication people will do some techniques. Okay, by using twin tube technique or n weld technique they will make the IC. Okay, so this is total ASIC design flow. Okay, so why rigorous verification and testing is happening in the VLSI, can anyone say? Am I audible? Hello.
Yeah. Can you
Yeah,
please
yeah.
repeat the question?
So these many steps are there, no? These many steps are there, no? So I explained all these steps. So in the ASIC, if you take so many rigorous verification and testing and all those designing is happening. Why this is happening? Can you anyone say?
Because, sir, as you said, na, that ASIC is that application specific.
Hmm. Hmm.
So, means like if it's once programmed for a specified application,
Hmm.
uh, that cannot be modified like FPGA. We can do again and again according to our need.
Hmm. Hmm.
That is not
Okay.
possible
Okay.
for custom.
Yeah. Yeah. Okay. What about others? I'm expecting something, some other answers from others. What about others? Yeah, who had told? Nishant Rai
Yes, sir.
and Sivaranjani, Pavan. I'm expecting answers from you. Are you there?
Yes, sir.
Yes, as
Yeah,
you
yeah.
said before, in FPGA we can reprogram the
Mm. Okay.
things
Mm, mm,
if things gone wrong.
mm,
But when it comes to ASIC, it is a application specific integration.
mm.
So we need to design uh, requirement. So I think there are more
Ah,
process
in
in this.
FPGA also, this backend, this PD will be there. No, this is actually given by the vendor. Means who is giving the board? It may be like Altera or Xilinx. Okay, so who is providing the board? All those softwares will be given by this that vendor, that company people. But here, this one we need to do different stages, different. Design engineers are required, like architectural engineers, RTL engineers, verification engineers, and synthesis engineers, DFT engineers, HTA engineers, PD engineers, verification engineers. So why this rigorous testing and verification is happening in the VLSI? So it will take around get into the IC into the market. It will take around 1 year of time. Okay, 1 or 1 depends on time to market. So I'm expecting some answers from you. Yeah, 1 second. So shall I tell you any answers are there from your side? Yeah, your answers are correct only. Yeah, whether it is correct or not, just that's why I'm telling. Yeah. So here, shall I tell? Hello.
Sir, in
Hmm.
FPGA, we can rewrite and in any
Yeah,
time,
yeah,
sir.
yeah.
In
I'm
ASIC, we
telling.
can't
Means
do
it
that.
may be ASIC or FPGA.
Yeah.
So, ASIC or FPGA, I told you, suppose this is ASIC flow, no? So, ASIC flow means this so many rigorous design and verification and testing is happening, no? So, means reality you think and tell me. So, reality. So, I told you are using this IC in automobiles, you can use in the flight control, you can use in security. Reality you think and tell me.
Sir, is it
Suppose,
related
like,
to cost?
yeah, tell me.
So is it related to cost? It will be wasted if the anything goes
Cost
wrong.
wise, no, no, no. Actually, like this, suppose if you are using this IC in simple example, I will tell you. This IC you are developing for uh, what airbags in automobile. Okay. So airbags, that IC you are using for automobile, suppose any accident occurs. Okay. So any accident occurs, after 2 seconds, the airbags will open. What will happen? Tell me. Suppose due to some there is a malfunctioning in the IC. So after 2 seconds, that any accident occurs during that point of time, airbag should open. Okay. After 2 seconds, the airbags open means it will lead to the damage of that automobile, that car, as well as damage of the life also. No. Did you understood what I am saying?
Yes, sir.
Suppose this IC you are using for aircraft. Okay. So any malfunctioning is there. Any malfunctioning. Okay. So it may damage to what, it damage to so many lives, as well as it will damage to property also. Property they can get profits, but lives once gone means they will get the lives. No, no. So that's why, so anyway, before releasing into the market, this VLSI IC will go into the rigorous verification and testing and synthesis, physical verification, physical design, all those things will be done. Did you understood what I'm trying to say?
Yes, sir.
Yeah, yeah,
Yeah.
okay, yeah. So design verification, okay, design verification. If you see, wherever you see, you have VLSI. Your computer, your mobile phones. Okay, now it means in your childhood, TVs are you got in terms of like big size, like CRT you got, but nowadays TVs are become I mean thin, no, smart TVs. That is due to what? VLSI only. So wherever you see like the automobiles, anti-lock braking system, engine control, or a household application, security. Okay, wherever you see, suppose camera, digital camera, okay, or video camera. Okay, all these things like IoTs. Nowadays IoTs are coming. Okay, wherever you see, you have VLSI. So mainly you studied about microcontroller, microprocessor, FPGA. I told you, no. So mainly zinc is one FPGA. System on chip. System on chip is actually your processor in your mobile is actually Qualcomm Snapdragon, no, or Apple A7 processor. That is actually we call as SoC, system on chip. Okay. So all the ICs makes into one single IC, we call as system on chip. Okay. So you studied about microcontroller. This is means it's a microcomputer, we can say. Like all the peripherals will be available in the same IC, like CPU, ROM, RAM. Okay. You studied about 8051 microcontroller, no? Have you studied or not in BTech?
Yes, sir.
Yeah. So that is actually basic microcontroller, and you have different types of Atmel controllers. Okay. So those are operated with some type of like we can interface peripherals to this, like I2C, UART, SPA. For this, for embedded related thing, we can use microcontroller. Okay. Microprocessor, I think x86 you studied. x86, that register set architecture and clock frequency, all those things you studied, no? So Intel i3, i7, AMD Ryzen 7, Ryzen 5 processors. You studied, no? Processor, actually, the difference between controller and processor means processor will do general purpose operations. Like in laptop, you have a processor. In desktop also, you have a processor. So you can do general purpose, general things, general like you can watch the videos, you can listen the songs, you can do some documentation, you can run some program. Okay. Whereas microcontroller means what? It is used only for specific application. Okay, that we call as we can call as application specific processor. We can call application specific processors. Okay, those are assets. we call as integrated process. Okay, and you have system on chip. You see here. This is actually system on chip. You have different peripherals are there. SRAM, flash, mainly ARM processors are there, and JTAG, Ethernet, MAC, SPI, CAN, USB, PWM. Okay, so mainly these are communicated with AMBA protocols. Okay, so AMBA means what? Advanced microcontroller architecture bus. Okay, so you have AHB bus, APB bus, okay, and AXA bus. Okay, all these buses will be there. Okay, so this will be operated. Okay, ఒకసారి మొబైల్ పవర్ పోతుంది. మొబైల్ ఈయనది పవర్ పోతుంది వస్తుంది. ఇది పవర్ పోతుంది వస్తుంది. హలో హలో actually there is a power cut in my area, sir. Actually that's why it's a problem coming. I will connect with my mobile. Just I will rejoin. Just to inform the. I'm rejoining. Yeah. There is a power cut, so it's coming and going. Okay. Yeah. I will rejoin. Yeah. 1 minute. Uh, Actually, hello. Actually, there is a power cut in my area. That's why due to this, there is a Wi-Fi issue. Okay. My voice is clear?
Sir, I think in between also before the
Yeah.
microcontroller, your voice
Yeah.
was not coming.
Please confirm
So
that only on.
I asked
Okay.
also several times that whether that is
Yeah.
your network issue or
Actually,
mine.
like, yeah. Sorry for inconvenience. Actually, there is a rain in my area, so power is gone. That's why my Wi-Fi has disconnected. Okay.
No issue.
Uh,
No issue, sir.
okay. Yeah. Just we'll 1 second. Yeah. So this is actually SoC, okay, system on chip, okay. FPGA means I told you, no, field programmable gate arrays. It consists of configurable logic blocks, IO blocks, and programmable interconnects will be there, okay. So like if you take the verification RTL design and verification course, so you can apply for FPGA design role or RTL role or verification role, okay. Different or formal verification also there. Formal verification means you are using some assertions, okay, assertions related. So many things are there. So many opportunities will be there. you can apply for different roles. Okay, if you are taking for physical design, only one physical design role will be available. Okay, as I told you, there are two types of target devices: FPGA and ASIC. ASIC is stand for application specific integrated circuits. FPGA stand for field programmable gate arrays. Okay, so this is actually FPGA flow. So mainly we are using Xilinx Vivado that from AMD. So first, what you will do, you will write the HDL code. I told you know synthesis. Synthesis means what? Synthesis will convert your code into gate level netlist (GLM). Okay, GLN, gate level netlist, and implement. In the implement itself, you have translate, map, place, and route. So mapping means you need to map to a particular board. Okay. So this translate, map, and place and route will be provided by the vendor only. Okay. So suppose if you are using Altera FPGA or Xilinx FPGA, so that will be provided. The software will be provided by these companies. Okay. And after that, you will generate the bit stream. Okay, you know that whatever the ICs are there, that will understand only zeros and ones, no, binary. This is
Yeah.
actually bit stream. Okay, so in the embedded lab also, at last you generated the hex file, no, hexadecimal file. Okay, so that will port into the FPGA, and FPGA will work as per your coding part. Suppose if you want to design for some simple FSM sequence detector, okay, some sequence detector, then your FPGA will work as a FSM. Okay, afterwards, suppose if you want to write for the counter, so counter code you write in HDL, and that HDL, that HDL, these things will be happen, and at last bit stream will be loaded into that FPGA, and FPGA will work as counter. Okay, so this is actually FPGA flow. Okay, and there are different closure techniques will be there. Functional closure, like simulation, you can verify your design. Power closure, okay, we can see for power related thing. And timing closure means like static timing analysis. I told you, no, with the timing related. And in digital, you are studying about only clock, one clock. Okay, either it may be counter or register. You are studying about one clock. There are some designs in the reality in the industry. There are different modules operating at different clocks that we call as clock domain crossing. Okay, here one example is asynchronous FIFO. Asynchronous FIFO is a one example for clock domain crossing. Okay, so you have different clocks. We need to synchronize one module with other module. Okay, both are operating at different clock frequency. Okay, and RDC is actually reset domain crossing. Okay, there are two types of resets will be there: synchronous reset and asynchronous reset. Okay, so this will study in the Verilog. Okay, what are the synchronous reset and asynchronous reset? And in this course, so I will teach you the basic digital electronics, and I will teach you the Verilog. Okay, VHDL I'm not teaching. Okay, and I will tell you two projects related to Verilog. Okay, suppose I will tell you I2C project, and some FIFO project also I will tell you. Okay, FIFO project, and if possible SPI also I will tell you. Okay, SPI, these projects. Okay, dual core RAM also, some projects I will tell you. Static timing analysis, linting I will tell you. And in the so this comes under the RTL design. Okay, verification means I will teach you the system verilog, and system verilog based assertions, and UVM also we will teach. Okay, this is total our course. Okay, so RTL design and verification. Okay, RTL design and verification. Okay, so that means the digital electronics is the basics for RTL design as well as verification. Okay, so Verilog and project, static timing analysis, linting, and system Verilog, assertions, and UVM also will teach. Okay, this is our syllabus. Okay, is there any, so this course is also called as ASIC SOC verification also. we can call, or RTL design and verification, RTL and DV, RTL and design verification. Okay. Is there any doubt in this course overview? Hello?
No,
Sir,
sir.
there is
Yeah.
no doubt in the course, but I have a question.
Yeah. Please ask me.
Like you told na, that 6 nanometer technology and 10 nanometer technology,
Mm, mm, mm.
that is the total distance between first and last, means gate to drain, or between gate to source and source to drain.
Suppose MOSFET, if you study, suppose like this is one inverter. Okay, inverter, this is A and A bar. Okay, so mostly you use CMOS technology. CMOS technology means what? So you are using PMOS as a pull up and NMOS as pull down.
Correct.
Okay, so PMOS as pull down. Okay, so
Mhm.
mainly the basic thing is what? This is PMOS and this is NMOS. Okay, so NMOS if you take, so here you have like P substrate, you have P substrate, you have N plus and N plus, and you have silicon dioxide, and here you have gate over here, okay, and here you have source, and you have drain, okay, source and drain. The distance between source and drain is channel length. This channel length we call as technology. WBL ratio, aspect ratio, you came across MOSFET, aspect ratio, width by length. Actually width of this transistor and length of the transistor. So this length of the transistor is 3 nanometer. They will design with they will design the transistor with 3 nanometer. Channel length is 3 nanometer.
Okay.
That is the technology. Okay. So
Okay.
you are integrating. You are like what you are making the transistor count double. No, every 2 years you are fabricating transistor with that much technology. Okay. So miniaturization. Miniaturization means what? Size goes on reducing. Okay. Example like if you see nowadays you are getting Samsung's flip phones. Okay, so flip phones how we are getting, that is due to technology only. Okay, yeah. I think your doubt is clear. Somebody asked you.
Yeah, sir.
Yeah. Okay. Yeah. Next. So what is the difference between Verilog and VHDL? So Verilog actually it will follow C syntax. If you are comfortable with C, it's easy to learn Verilog. Okay, this is a high-level language, easy syntax, easy to learn, and multi-level abstractions will be there. Different types of abstractions are there, like switch
Very,
level, gate level, data flow level, and behavioral level. Okay, so simple. These are HDLs. We call as hardware descriptive language. So HDLs are nothing but in digital you are going to study about the combinational circuit and sequential circuits, how you are describing your circuit in terms of textual format we call as HTL. Okay. In terms of programming we call as HTL. Okay. So basic AND gate you take. Basic AND gate. This is a basic AND gate. Basic AND gate A, B and Y equal to what? A and B. Okay. So how you are writing module? My module name is AND underscore gate. Input A comma B, output Y. I am using a continuous assignment statement assign Y equal to A and B. In terms of expression I am writing and end module. Okay. So within how many lines of code my code is completed?
सर जी हमको ठीक लग रहा है.
3 lines of code my code is completed. Okay. Can anyone say what is the full form of VHDL?
Very high level descriptive language.
Very high speed. Very high speed integrated circuits, hardware descriptive language. Okay. So VHDL, this is a VHDL. Okay. So this is hard syntax, controlled language, and hard to learn and multi-level language. So this is the old language. Old language means it will follow. I think you know Ada and Pascal. This will follow this language, Ada and Pascal. Okay. So mainly this is security wise, it is very famous. They'll use in the defense, okay, and telecommunication. They'll use this VHDL. Okay. Simple, same AND gate you take. So you need to write library IEEE use these are the header files. Use IEEE.std logic 1164.all. You need to write, you need to declare the inputs and outputs in this entity and underscore gate is port. You need to declare A is in HTD logic, B is in HTD logic, Y is out HTD logic. And in the architecture, you need to write this one. Okay, architecture of AND gate is begin Y equal to A and B. So how many lines of code it took? Mostly 12 to 13 lines, no? Will you agree?
Yes, sir.
Hello. So which one is easy to learn? Which one is easy?
Very long.
Very long.
Verilog. Verilog is easy. Verilog is universal. For the ASIC, you will use RTL engineers, you will use Verilog only. Okay. So everything is interrelated. Suppose if you know the digital electronics, this is the Bible, or we can call Bhagavad Gita for RTL front end engineers, RTL and DV. Okay. So after digital electronics, you need to study about Verilog. Okay. So if you know digital electronics, you know Verilog. If you know Verilog, you know system Verilog. If you know system Verilog, you know UVM. Everything is interrelated. We should not skip anyone. If you know all this, you can develop a project. You can develop a project. Okay. So this is about today's session. So as you know, what are the top based product based companies? You know, Samsung, Intel, TSMC, okay, Qualcomm, Nvidia, Broadcom, MediaTek, like this. So many product based companies are there, and established service based companies like some service based companies, Capgemini, HCL, Wipro. So Capgemini, they are making some special drive for women's also. Okay, for women's it's a very good opportunity. Okay, so Capgemini, Samsung, okay, USD Global. So apart from this, 1,000+ service-based companies are present in Hyderabad, Bangalore, Noida, and India. Okay, so as per VLSI is booming. Okay, so within this 5 years of time, we need some 1 to 2 lakhs VLSI engineers. Okay, why? Because due to Corona, that exporting of chips are very difficult. Due to that, that effect has happens in the all the product related. Everywhere you see VLSI ICs are there. Okay, so we realized and we going to set up our own fabs. Tata came and they are going to set up our own ICs, okay, own fabs. So for this, design engineers are required, okay, RTL engineers are required, verification engineers are required, PD engineers are required. So much scope is there in the VLSI, okay. It's a good time to enter into the VLSI, okay. Yeah, this is about this session. Any questions? Please ask me. Hello.
Hello.
Yeah, yeah.
Sir, can you please suggest some prerequisite subjects so that we can get prepared before the next classes?
Prerequisite subjects. Okay, okay.
Topic, sir.